Hi guys, my name is Gus Nalwan and I'm the head of AI and machine learning at Accelerometer.com, and I'm also an AWS machine learning hero. Today, I'm going to tell you a story about how I built an AI tech to help my wife to choose what clothes to wear. Before I start, let me introduce you a little bit about myself. I work for a company called carsales.com. We own a portal which facilitates car buying and selling. We have both private and dealer car, and at any given time we have about 230,000 cars, with 5,000 cars coming in every day. Apart from cars, we also have bikes, boats, trucks, and caravan. My passion in the past 5 years has been all about AI. I was so impressed with AI because I can use it to solve problems that I wouldn't be able to solve before. And I'm so fortunate that I work in a company where I can apply my passion in solving business problems. So me and a bunch of other guys in my team, we're building all kinds of AI tech. And one thing that in particular that I want to mention is Cyclops. We built and deployed this tech about 4 years ago, which is an image recognition which identifies car from just a single photo. This technology is driving our mobile apps to help seller to identify their car without even telling us what it is. We know already from the photo. Another tech that I want to mention as well is called Mystique. This is a tech that we deployed late last year, which identifies the location of Rego plate in the photos and blurs them to protect your privacy against Rego cloner. As an AWS machine learning hero and a tech evangelist, I'm also passionate about sharing my experience and knowledge to the community. And the reason is because I want to grow our AI ecosystem, especially in Australia. And I want to change many people's perception because many people still believe that in order to jump into AI industry, they have to be very, very good at math and have to have a PhD degree. And this may be true 4 or 5 years ago, but as the years goes by, it has changed dramatically. There are so many open source code that's so easy to use. There are so many of high-level tools to use that helps you build AI tech without understanding the technical details behind the scene. Especially one in particular I want to mention is AWS SageMaker. And it's super easy to use. All you need to do is just know how to prepare your data, collect the training sets, label them, clean them properly, start the training button, and then here you go. You got the model at the other end. And of course, you still need to know how to do the evaluation, make sure your model is performing well. But with this tool, it's so much easier for you to do now. Back to the topic. How do I build an AI tech that solves my wife's problem in choosing clothes to wear today? I'm very sure many of you will wonder, why do I build this? And where is this idea coming from, right? So it's actually coming from the question that Yumi, my wife, give me every single morning. So she's facing towards her wardrobe, starting on all kinds of clothes that she owns, and she'll ask me, what should I wear today? And this is what my face looks like when trying to answer that question. And first of all, I have no sense of fashion, so it's very hard for me to actually give a good opinion, right? And then second, I have a very bad short-term memory. I couldn't remember what she wore last week, or the week before, or the month before. And you need this information to be able to recommend something with more variation, right? You do not want to wear the same clothes again and again. So instead, why not I use what I'm good at, which is building an AI tech, to build something that actually can help her to recommend a clothes, or at least to help her to decide what clothes to wear, right? And will it be even cooler if this AI technology knows if it is a sunny day, it can recommend her a skirt to wear. And if it is cloudy, recommend her a hoodie. So it's a weather contextual. Awesome, right? So then I start brainstorming with myself. What kind of information do you need in order for you to recommend or decide what clothes to wear? So I gather the first thing that you need is what do you wear recently, right? So you do not want to wear the same clothes again and again. Yeah. So you need to know what you wear last week and yesterday and the week before, right? So for this, you need a fashion diary, which record what you wear on this 18th and on the 19th, right? Second piece of important information is what do you own today, right? So of course, if you want to recommend an item, you need to know what are these items to recommend. Yeah. So for this, you need to build a cloth catalog, a catalog which record every single unique clothes that she owns. Like in this case, it's a spotty coat, funky trousers, and a pink t-shirt. And finally, using the fashion diary and the cloth catalog, then I can build a recommendation engine which then can recommend her a cloth to wear. And as an experienced software developer, you always have to start with scoping your MVP, right? So the first step is to build a fashion diary. Yeah? The next is the cloth catalog, and finally a recommendation system. And I've built the first two components, not the recommendation system yet, but today, due to the time constraint, I'm going to focus all my talk mainly talking about just the first one, the fashion diary, with touching a little bit about the cloth catalog. Yeah? If you want to know more, you can actually ask me a question later, or you can actually reach me out after this event. So, how do you build a cloth catalog? The easy way is just simply walk off to her wardrobe, right, and take out every single cloth that she owns, put it on the bed, and take a photo of every single one of them, right? It's easy. However, the issue is what happens if she go out and shopping and start bringing in more and more clothes. I have to take a photo of every single one of these new clothes, right? So this solution does not really scale. Yeah. So every time she went out shopping, I have to do this again and again and again and again. This is not good. So what I need is actually an automated system which automatically does all of this for me. Yeah. So what if I put a camera somewhere in the house, yeah, facing towards the front door, right? And when Yumi walk past, it take a snap of her, right, and then record in database. And then on day 2, when she wear different outfit, it take another shot and then store it in database, and so does in day 3. Awesome, right? This is exactly what I need. And as the days goes by, day 3, day 4, day 5, I have a collection of what she wear, and this is exactly what the fashion diary that I need, right? And finally, once I have this component, I can simply pass all of the snapshot to this cloth identification system, which then curate the unique one only and store it inside another database, which is basically just a cloth catalog. As you can see here, these are the only 3 unique clothes from those 5 days that was recorded above, right? Red skirt, spotty coat, and a pink shirt. So let's start with building the fashion diary. How do you build one? Of course, you need a camera, right? But the camera itself is a dumb hardware. It does not know what it is looking at. It won't know whether there is a person in front of it or not. So in order for the camera to know whether there is a human presence, it has to be connected into an AI system. And an AI system needs to run inside a hardware with a GPU, especially if you're dealing with computer vision, which is what we are now. And this hardware normally is computer, but computer is too bulky and expensive, right? And it's too excessive. So there must be a better way. Luckily, there is this AWS DeepLens. This device does all we need. It has a 4 megapixel camera with 1080p resolution, and it is GPU enabled, and it's only $250. And on top of that, it's 11 by 6 centimeter in dimension. It's super tiny. This is perfect device for us. So I got myself one and start hunting down a location where I'm going to put this AWS DeepLens. And I found a perfect spot. It's on this cabinet facing towards the front door. And you probably wonder why the front door? Because it is contextually suitable. If you remember, we want to build a system that recommends her an outfit to wear to go out of the house. I don't need to record a clothes that she wear indoor, like the PJs, right? All I need to record is what clothes that she wear to go out, so I can actually use that as a way to recommend her another clothes to wear to go out too, right? And you probably wonder, what happens if we just go out to throw out garbage, right? You do not want to record that as well, right? So the solution for this I will reveal later, closer to the end of the talk. So for now, let's hold that thought. And next reason is safer. So initially, I was thinking of putting this camera on her wardrobe, yeah, where she's putting on clothes and trying it on, right? That sounds like the perfect place for it. However, our wardrobe is next to the bathroom, where a lot of the time you can come out naked there, right? So that means I have to build another AI model that makes sure that detects if there is a naked photo and block them, not to send them in the cloud. And if the AI model fails just once, and this photo somehow leak into the cloud, I'll be in a very, very deep trouble, right? So definitely wardrobe is not a good place. Then front door it is. So now I want to show you what does the AWS DeepLens software stack looks like. What is inside this AWS DeepLens? So the first component is actually, I have a Lambda function running there. Yeah, this is where the logic of your system actually running. Yeah, and this Lambda function is connected to a human detection AI model, yeah? And also connected to the camera. The camera is a video camera continuously sending an image. It's like 10, 20 images per second, right, into your Lambda function. And my Lambda function then pass this image individually into my human detection AI model, which detects the presence of a human. And if it found one, it will crop the image where the human is and send it through the MQTT protocol to the cloud, where my other Lambda function runs. This Lambda function then sends this image into Amazon Recognition to do a facial recognition. From this, then I know who this person is. If it is Yumi, then I will record the image into the S3 bucket and record the entry as well in the Amazon RDS. Yeah. So now, in the next few slides, we're going to focus on just what's happening inside the AWS DeepLens. Yeah. Once you activate your AWS DeepLens, the first thing that you want to do is deploy your AI model. Yeah. The good news is there are a few built-in AI models already provided for you, and there is a good chance that one of them can already do what you want, which in my case, I choose an object detection model which can already detect 20 popular objects including human faces. So all I need to do is just to select it and hit the deploy button. Another thing I want to mention as well, in AWS DeepLens control panel, once you register your device, they will give you this IP address. Yeah? This IP address is super handy for you to be able to do debugging. If you drop this IP address into your web browser, voila, finally you can see what the AWS DeepLens sees. So this is really, really super useful for you to debug your application. And not just being able to see the view, but you can also drop in some annotation, some text, some bounding boxes, circle, whatever it is, to help you do further debugging. Yeah? So here you go. My human detection AI model is running successfully. As you can see, it detects the presence of a Yumi there, right, with a blue bounding box. However, I also notice slight problems here, right? It detects a body where there is no face visible. And you probably wonder why I do not want to detect body with no visible face. If you remember this architecture diagram, yeah, if you go back slightly, you remember that at the end of this process, I actually need to check whether is that Yumi's face. If it is, then I actually save the entry into the database and save the image into my S3 bucket, right? So if there is no face, there is no point to send it to the cloud and to do this detection to begin with, right? Then I have to tweak this logic a little bit. I need to only send the face, the photo, if a face is detected. What it means then, I have to change my human detection AI model into human and face detection AI model to know whether there is face and a human body. So it's quite clear. My next step will be to build a human and face detection, right? Given an image, I need to be able to come up with a bounding box. Where is the body and where is also a face? So luckily, we have Amazon SageMaker to make this job super easy. All I simply need to do is just to prepare the training sets, which is just a bunch of thousands of images with the bounding box of where the face is and where is the body, right? So we also call it a label training sets. We pass these training sets into Amazon SageMaker, hit the start training button, and you end up with the OI model automatically. Yeah. However, even though building the model itself is super easy, you still need to spend effort to label them, right? You have to bounding box every single human body and face. With the human body, it's not hard because I simply just downloaded the open source Pascal datasets with come with a bounding box already. However, there is no bounding boxes for face. So rather than me spending months of labeling these images manually, so what I do instead is a bit of cheating. I actually pass these images into Amazon Recognition. It's actually an off-the-shelf AI service by Amazon, which already detect popular objects, including human faces. So I got recognition to bounding box the face for me, and I put it back into the training sets. Here you go, I have the final training sets. And my next step will be to build the model, and it is super easy. I just need to go to Amazon SageMaker control panel, choose the algorithm, which is in this case object detection, and I choose the base network of VGG16, and with the pre-trained parameter to be true, so it's called transfer learning to expedite your training process. And in total, I'm using about 8,600 images. And 3 hours later, I have my model built. And now it's time to import and deploy into my DeepLens, right? So all I simply need to do is to go to AWS DeepLens control panel and choose import model from SageMaker. And I choose the job ID there and hit the import button. And I got my model imported, and now I just need to press the deploy to device button to actually put this model into the device. And here you go. Now I have the face and body detected. You can see in the bounding boxes there, right? So, problem solved, right? Not quite. There are still a few problems to solve along the way. So, first problem is I'm still seeing an image like this, which is basically like a passerby, yeah? So Yumi just passing by the front door, passing through the DeepLens and got captured. And well, the face is visible, the body is visible, then it triggered the logic and sent the image to the cloud. I do not want this kind of images, right? Because it did not intend to go out of the house. So as you can see, she's wearing PJ there, right? The second problem, I'm seeing like hundreds and thousands of these images. This is actually a photo of my mother-in-law, yeah? And as you can see, she's very active in the kitchen. And in this case, actually, she's making dumpling. Her dumpling is like the best dumpling in the whole world. I cannot complain. Despite her best dumpling in the world, I do not want to actually spend that much money to do facial recognition unnecessarily in the cloud. I call this strategy is a mother-in-law avoidance strategy because she's the one who contributing the most of the problem. Apparently, the solution is quite simple. Really just need to actually set up a detection zone. Yeah. So that red box here is a zone that actually set up to tell the logic that if the detected bounding box is fully inside this box, then send it to the cloud. Otherwise, do not send it, reject it. And that's it. 2 problems are solved. So I got rid of my mother-in-law. Well, not literally, but digitally. And I got rid of the passerby. Back to the architecture diagram. The top part, which is the fashion diary, is completed. And as I said, for this talk, I will not discuss too much details about the closed catalog. So, with the fashion diaries completed, all I simply need to do now is actually to add an extra Lambda function, which got triggered when an entry is added into the database, yeah, to call the weather bureau, to check for the weather, what is the weather today. So I can tag every single entry with the weather. And I also spend time to build mobile apps, so she can actually have this app running on her phone, and she can use this to browse through and see what kind of clothes that she's been wearing in the past few weeks, few months, to give her some inspiration of what she needs to wear today. So if you remember in the first few slides, I mentioned about how do I avoid taking a photo of her going out of the house, not intending to go out and meet people to go somewhere meaningful. For example, like just throwing rubbish, right? So initially, I was thinking of actually adding the GPS tracking, location tracking on her mobile apps, right? And then I can detect whether she's far from home or she's just nearby. But I know that this will trigger some privacy concern, so I quickly decided, okay, this is not the way to go, right? But instead, I found an alternative solution. I actually added an accelerometer tracking, so basically checking the speed of her movement. With this now, I can actually find out whether she actually go out for meaningful purpose, because going out for meaningful purpose require her to either drive a car or take public transport, right? So which is faster than the walking speed. And besides, I have an extra bonus. With this technology now, I can actually got an alert when she's speeding on the highway. Alright, so without further ado, I'm going to show you what the final apps looks like. Okay, just as a clarification, I do not need this technology. If you see myself there on the app, it's just because I needed to do debugging investigation, and it's very annoying. You have to keep asking her to actually come in and do and post here and post and there, right? So it's easier for me just do it for the sake of debugging purpose. That's why you see me there. So for the takeouts, deploying an AI technology on the edge is quite easy using AWS DeepLens, as you can see yourself. And with SageMaker, you can expedite building your AI model. And if you want to know more technical details about this project, especially the cloth identification system, which I did not get a chance to cover today, please follow my blog below. And you can also find me in LinkedIn. Thank you for listening, and if you have any question, it's time to ask.